So now in the complex plane, and the complex plane really isn't too complex. It's pretty much identical to the regular axis and how you just normally do it and you're used to in Cartesian form. So continuing forward, we have our, hopefully you remember from last video, so z equals the real part, which is x, plus the imaginary part, which is iy. And so we'll do a little example where z is equal to 2 plus 2i, and just to make a little note in your memory that actually every number is technically a complex number. Just in high school and first year and wherever you're learning, even just learning from the internet at home, which is great. I fully endorse that. But say 2, we could write 2, which is just most people view as a real number. We could also write it as 2 plus 0i. So, every number is a complex number. We don't always treat it that way, but it's just something to store away in the back of your mind. So how would we plot 2 plus 2i? Well, the x-axis is the real axis, and RE is just short form for real. And the y-axis is the imaginary axis, just IM is short form for imaginary. So, it's the exact same as you do the points in Cartesian form, just dealing with real numbers. So this is the point 2, 2, and this is how you typically write it, but some people write it as 2 plus 2i. But, usually you're fine just writing 2, 2. And that's it. So that's how you would represent a number just the exact same way in Cartesian form. But then you'll also want to know how to work in polar coordinates. So in polar coordinates, remember we swap xy with your radius r and then your angle. And hopefully you've been exposed to this before. If not, there's a lot of videos. I recommend watching some of those. But just the basics are, you start on your polar axis, and then you trace out, moving with your angle theta, counterclockwise from the first quadrant to the second quadrant, third quadrant, fourth quadrant, and that whole way around the circle once is equal to 2 pi. Over here is just equal if your angle was pi. But, so how do we convert now from this form to polar form? Well, you'll remember from SOHCAHTOA and the Pythagoras theorem that cosine theta is equal to x divided by r. Therefore, x is equal to r cos theta. We just multiplied r on both sides of this equation, dealing with this case here, ka. So cosine theta equals the adjacent divided by the hypotenuse. So the adjacent is x, hypotenuse is r. And then likewise, so dealing with sine theta equals the opposite over the hypotenuse, so y divided by r, simple rearrange, and y is equal to r sine theta. So now we have our new equation, so z equals x plus iy, which equals, well, x we can swap with r cos theta plus I times r sine theta for y. And some people, well, just to be clear, this part is still the real part in the polar form, and this part is still the imaginary part. But some people like to swap this r out, so they bring it out front, so r times cosine theta plus I sine theta. And this, in a future video, will deal more with this, but this is very useful as well. So this is equal to r e to the I theta. And so that's how we'd get the x and the y, and we'd convert it. But to get the r, well, remember from SOHCAHTOA as well, that the hypotenuse squared is equal to the adjacent squared plus the opposite squared. So r is just the square root of x squared plus y squared. In this case is 2, 2. So 2 squared 4 plus 2 squared 4. So our radius here we know is equal to the square root of 8. And then if you want to get the angle here, well, just to complete it, TOA. So tan theta equals opposite divided by adjacent. So opposite is y, adjacent is x. And so therefore, theta is the tan inverse of, well, y is 2 and x is 2. So it's tan negative 1 of 1, which is just equal to, well, just think about this in this example here too. This angle is going to be pi divided by 4. And if you're familiar with the unit circle, you'd remember that as well. Pi over 4, and up here we'd have pi, or I guess we'd be working in polar, so this is 0, this is pi over 4, and pi over 2, we got pi. Down here is 3 pi over 2, and then over here we're back to 2 pi again. So our angle is pi over 4, and so we can represent this as the square root of 8 with our theta, and our angle is pi divided by 4. Okay, we'll get more into this in the next video.